we're going to dive into quadratic functions. And what a quadratic function is, it's of the form where your parent function is x squared. So I may add stuff to that, I may subtract stuff to it, I may multiply, I may divide, but that's my basic function. So if I add, subtract to it, if I multiply to it, whatever, as long as my largest exponent in polynomial form is an x squared. So what that means is no negative exponents, no rational exponents, anything like that. So this is quadratic, and that's the parent function. So I've got a couple of options here. I can make him open upwards, and I can also make him open downwards if I lead off negative. Okay, so I know that. So this one over here would be y equals a negative x squared because I flipped it. So we want to look at a few things that make quadratics unique. So if I'm going to graph a line, we've always screamed about the slope and the y-intercept, or where it hits the y-axis. Well, there's a few more things that make quadratics unique from one another. So we're going to talk about the vertex. And that is where there's a change in direction. So in this case, my vertex is here. So notice that that's the lowest point because it opens upwards, okay? And then there's the vertex there, and that's going to be the tallest point because it opens downwards. So in this case, we would call the vertex a minimum because it just happens to be the lowest point of the graph. And in this case, we would call the vertex a maximum because it's the tallest point of the graph. So it's still a vertex. It just happens to be that we can also say that it's a min or a max. So I want to figure out how can I determine what the vertex is if I don't have a picture. So we've got two ways of doing this. If you are in trinomial form, what you are going to do is, and that's going to be an ax squared plus a bx plus a c. So notice that both of these are in trinomial form. It's just that my b and my c are both 0. So this is still in trinomial form. What I'm going to do is create my x coordinate of the vertex to be negative b over 2a. And I'm going to take that value and evaluate it in the function, and that's going to give me my y coordinate. So that should look familiar to you because it's awfully similar to a part of the quadratic formula. So negative b plus or minus the square root of b squared over 2, or minus 4ac all over 2a. So this is the part of the quadratic formula that does not include the radical. Once you know what that number is, plop it back inside your function and tell me what the y coordinate is. So that's how I'm going to find the coordinates of my vertex if I'm in trinomial form. Well, what happens if I'm in vertex form? And vertex form is going to take the form of a times x minus h squared plus k. So notice that you've got a chunk being squared. So that chunk is squared. Then you've got a number plus or minus this number off on the end. This can be a 0, and this can be a 0. So it's okay. In other words, if I have something that just has that part, okay, that's fine. I know what my vertex form is. It's just that your k is 0. Well, in this case, your vertex would be h comma k. So be very careful. When you pull out this h value, whatever's being added or subtracted to x, when you pull that out, you're going to change its sign. So go back to the last lesson that we did. What happens if you add or subtract something directly to the x? It shifts it to the left or to the right, and you always do opposite of what it says. So you're telling me how far this parabola shifted to the left or to the right. On this one, you're going to tell me it's a plain old number hanging off on the end. You're going to tell me how far up or down your parabola shifted. So this is just a nice little convenient way to figure out either through trinomial form or through vertex form what your actual vertex of the parabola is. Okay, so another thing that we're kind of interested in is going to be your x-intercepts. And that's going to take us back to, you actually know how to do that. And honestly, this is the only new part for today. The rest of this you already know, we just have to remind you of it. So for your x-intercepts, you're going to take your quadratic and set it equal to 0. And solve. So that's going to require some factoring or some completing the square or square root method, or even if we have to, we need to go to quadratic formula. But this, your basic one, is going to be either factoring, and you can have completing the square. You can have square, I did not even put enough room here, square root method, or the Queen Mother Mary quadratic formula. Okay, so those are the ways that we're going to solve for your x-intercepts. Usually we want it equal to 0 unless it's just absolutely screaming in our face that there's an easier method. Okay, but normally we'll go ahead and set it equal to 0. So that's your x-intercepts. Well, now I need to know what my y-intercept is. Okay, so my y-intercept is going to be where this thing will hit the y-axis. So if I want my x-intercepts, I kill my y value and make it 0. So I'll have all of my x's equals 0, which is your y value. If you want your y-intercept, kill your x's. So we're going to sub in a 0 for x. And then simplify. So that's going to take the form of 0 and a number. Whereas these ones will take a form of a number, comma 0, and a number, comma 0. There may only be one of those, but that's what we're looking for. Okay, so now I know my vertex, I know my x-intercepts, I know my y-intercept. So now we want to talk about domain and range. So domain, hang on, I cannot flip my paper. Domain is going to be all the x values that are covered. So let me give you a hint. Hang on, what number are we on? Number 4. Okay, so domain is going to be all x's that are usable. Say, come back up here. Do you see any variables in denominators? Do you see any variables under even roots? No. Guess what your domain is? Your domain is going to be all real numbers for all quadratics that open up and down. Okay, if I want to like freak you out and turn these things to where they open up sideways, then your domain would be restricted because you wouldn't use anything on this side or you wouldn't use anything on this side. But we're not doing that to you. What is your range? So my range is going to be all the y's produced when you use all those x's. So your domain is going to be all real numbers. But what is your range? And your range is either going to be, if it opens upwards, it's going to start at the vertex and go up. So if it opens upwards, it will start at the vertex and go up. If it opens downwards, it's going to start in negative infinity and go to the vertex. Okay, and that would be positive infinity. I should probably tell you that. All right, so if it starts, if your range, you always start from lowest to tallest, so it'll be at the vertex and go up. Or it will be in negative infinity and hit the vertex, one of the two. And then the last thing that we want to do, which we already know how to do, is increasing or decreasing. And none of these are going to be constant because they're all parabolas, and parabolas do not have any constant parts. So in this case, if I look at this top one, ignore him. Okay, he'll be decreasing right now because he's dropping down as we read from left to right. So again, we're looking at the vertex because the vertex is where it's going to change direction. Then if I look at this part, now he's going up, so he's increasing. So from the x coordinate of the vertex on, he'll be increasing. So that is probably everything that you ever needed to know. Look at x coordinate of your vertex. That is probably everything you ever wanted to know about quadratics. But we're going to come back in a second video and do some examples.